Okay, so I am Elsa Sharu Johnson from NIT Tiruchirappalli. So some of you might have seen me last 2 weeks. So today I'll be discussing with you week 3 questions and assignment questions of week 3. There was a previous discussion class yesterday where the person Abhijit might have discussed with you the basics. So I'll also go through the basics of the week 3 portions, as well as I will discuss with you the questions of the previous assignment, which will help you to solve the assignment of week 3. Okay, so we'll start the session. So yes, let me just check if everything is in order. So yes, okay, so random phenomenon. So you had dealt with random phenomenon this week, and the phenomenon or experiments whose outcomes are not predictable with certainty are called random phenomenon. For example, so in that random phenomenon there is sample space. So for example, if you look at this particular die, there are different faces for this die. 1, 2, 3, 4, 5, 6 faces are there. So the sample space for that particular experiment, that means the set of all possible outcome of an experiment will be S is equal to 1, 2, 3, 4, 5, 6. That is the sample space. Okay. So in between, if there is any doubt, you just put your questions in the chat window. Okay. So in that itself, in the sample space, event is any subset of sample space, and it is given by E equal to 4, 5, 6. So if you are taking the cases where the die shows 4 or 5 or 6 in that, then you can say that it is an event. Okay. So this event will be the subset of the sample space. Okay. So the next thing you have seen is probability. So probability is a measure that assigns a real value to every outcome of a random phenomenon. Okay. So the probability usually will be a ratio. So now you have seen what is an event and what is the sample space. So you can say that it is the ratio of number of ways an event can happen to the number of ways the sample space is present. So for example, the probability of, maybe if you are taking the case of a die, and maybe you are checking like the probability of getting odd number in a die, then the events will be like the odd numbers will be 1, 3, 5, and the sample space, so n of E, the number of E will be, in that case it will be 3, and sample space, as you have seen in the previous slide, it will be 1, 2, 3, 4, 5, 6. So in that, the number of the n of S equal to 6. So the probability of E you can tell as 3 divided by 6, that is equal to 1 by 2. Okay. Then the axioms of different axioms are there for probability. So that is like 0 less than or equal to P of E, probability of event, less than or equal to 1. So probability is always non-negative and less than 1. Then probability of the sample space will be equal to 1. That means the probability of entire sample space is 1. And probability of A union B equal to P of A plus P of B for 2 mutually exclusive events. Okay. Next we will move on to a question. Okay. So this question is like a word is given. Okay. It's bird. So I think you can answer this easily if someone has joined last class also. So it's like one word is there known as bird. Okay. And a random word is picked from this word. Okay. So we have to find out the probability that this will start with B. So there are many variations in which you can rearrange this word. Okay, so the total all possible jumbles can be given as the sample space. So the sample space will be like 4 factorial, because that much number of jumbles are possible in the whole word bird. And then what you can say is like, you want to find out the probability that will start with B. So your event is like jumbles starting with B. Okay, your event is jumble starting with B. So that can be told as 3 factorial. Why? Because after that you will be fixing the word B, and then you will be checking the variations in which the other 3 letters can be alphabets can be arranged. Okay, so you can see here B, IDR, RID, RDI, every different variations can be done. All these variations have their starting alphabet as B. So this particular number of events can be given as 3 factorial. So the probability of E can be given as n of E by n of S is equal to 3 factorial by 4 factorial. That means, how can you calculate the factorial? Factorial will be like, it will be equal to 3 into 2 by 4 into 3 into 2. So it will be 1 by 4, that means 0.25. Okay, so this is how you will find out the probability. Now we'll move on to the events. So these are all the summary of what is being taken in the week 3 sessions. So we'll see the events. So events, mutually exclusive events are the occurrence of one event implies that the other event does not occur. Okay, so for example, if you toss a coin, there is either the probability of one head coming up or the probability of one tail coming up. Okay, so if the head has occurred once, that means that the tail won't occur. Okay, so the coin toss gives either the head or tail, or it gives either the head or tail and not both. Okay, and other type of events are known as independent events. So two events are independent if occurrence of one has no influence on the other. Okay, so that is independent events. So okay, so then landing on head, for example, is like landing on heads after tossing a coin and rolling a 5 on a single 6-sided die. So these two events are like independent events. Okay, the getting a head on one throw does not depend on getting or rolling a 5 on a 6-sided die. So they are independent events. So in between, if you have any doubt, you can ask. Okay, so next one, how will you represent this in Venn diagrams? So here you can see this is S denotes the sample space, E is one type of event and F is another type of event. So the colored region here shows E union F. That means both events are occurring and they have some intersection also. Okay, so the colored region shows E union F. Now if you want to see where the events are happening together in both the sets like E and F, the colored region shows the intersection. Then in this one, the E represents the event and E complement represents the place where it is not E complement. So for example, if you say the event for a die of getting odd numbers on the throw will be given as the event, then the events that give that the die throw will give even numbers will fall on the E complement space. Okay, the total sample space will contain all the throws of the die. Okay, now then this means that event E and F are present and F event is a subset of the E event. Okay, Now we'll move on to the conditional probability. So if two events A and B are not independent, this thing happens. So if two events A and B are not independent, then information available about the outcome of an event A can influence the predictability of event B. Okay, so in this case, one condition is that A and B shouldn't be independent. So if you want to see the probability of B, given the probability of given A event has happened, can be given as P of A intersection B by P of A. Okay, so we'll see an example. Two fair coins are tossed. Event A means the first toss is head. That is the event A. So first toss is head means HT as well as HH. And event B we are naming it as for the event which gives two successive heads. So that is only the case with HH. Okay. So independently, if you look at the probability of event A, then event A is like number of A by number of sample space. So number of events happening in A, number of cases happening in event A is HT and HH. So there will be 2, and the total number of events is HT, HH, TT and TH. Okay, so the total number of events is 4. So in that case you will be getting 0.5. And the next one, two successive heads. There is only one case like HH. So P of B will be N of B by N of S. That will be only one case is present there. So P of B can be written as P of B can be written as 1 by 4. That means 0.25. So now if you want to find out P of B given A, okay, then you have to see P of A intersection B. So you can check from here. P intersection, if you see, there is HT and HH here and there is HH here. So you can say P of A intersection B is, you can see which event is common in both. So only one event is common in both, right? Okay, and P of A. Okay, so only one event means that is like 1 by 4, you have got 0.25, right? For HH you have got 0.25 and P of A you have got as 0.5. So the answer will be 0.5. Okay. Now random variable. So a random variable is a map from sample space to a real line such that there is a unique real number corresponding to every outcome of the sample space. Okay, so the coin toss sample space HT map to 0, 1. Okay, so you can say that maybe it is like the number of tails coming up can be your event. So 0 tail will be 1 and conditional probability, total sample size. This one is probability of A, Srinivas. Total sample size means there is HH, HT, TH, TT, right? So 4 will be there, and one of the events is HT and HH. Okay. So as I was saying, random variable, it's a map from sample space to a real line, okay, such that there is a unique real number corresponding to every outcome of the sample space. So for example, there are discrete random variables as well as continuous random variable. In discrete random variable, a variable that take one value from a discrete set of values. So dice rolling, there are 6 different values. Okay, for example, in the other case, the variable that can take continuous range of values will mean the temperature of the week which is recorded, like 28.3, 21.0. So this will be like showing a continuous graph. Okay, So there are two types, discrete random variable is there, continuous random variable is there. Then according to that there is probability mass or density function also. So probability mass or density function, its main objective is to assign the probability to every outcome of a sample space. Okay, so you have seen the discrete random variable as well as continuous random variable. Then assigning the probability to every outcome of a sample space is known as probability mass or density function. Okay, so probability mass function is used for discrete random variable and probability density function is used for continuous random variable. So okay, so probability mass function, p of x equal to p of x equal to x. Okay, example, you can give p of x equal to 0 in coin toss 0.5 of one case, x equal to 1. So in this case it will be like getting a tail or getting a head. Okay, so x equal to 0, so if your event is like getting a head, then x equal to 0 means tail has come up. Okay, so anyway for both cases the probability is 0.5. Getting a head, probability of getting a head is 0.5, probability of getting a tail is 0.5. so it will be coming like this. And probability density function is given as p of a less than x less than b is equal to p of a integral from a to b f of x dx. Okay, so you can see an example right now. So it's given as a box contain 20 defective items and 80 non-defective items. We are selecting 2 items without replacement. What will be the probability that both items are defective? So you can see at as a total there are 100 items, 20 defective, 80 non-defective, and from this you have to select 2 items. Okay, so in this case you can see that the probability of both items defective, you are checking that probability of both items are defective. Only 2 items are taken and in that both items are defective. So how can you find it out? So the probability will be like the denominator will be the total number of cases. So you are having 100 total items in that, and from that you are selecting 2. So you will say 100 C2, combination of 2 from 100 elements. And okay, so you have, I think you have learned permutations and combinations. So this is the total number, and now you have to see both elements are defective. Okay, so that means that 2 defective and 2 non-defective. Anyway you are taking 2 items only, so anyway 2 of them are defective and 2 of them are defective and 0 are non-defective. So then you can say like how many total defectives were there? 20 defectives were there, and from them we are selecting 2, and this is the same case, that's why I am putting multiplication, and 80 C0. Okay, so you have to solve this one, and then you will get, so 20 C2 will be coming like 20 into 19 into 18 factorial by, just I will do this thing, 20 minus 2 factorial into 2 factorial into 80 C0, meaning like 80 factorial by 80 minus 0 factorial into 0 factorial. Okay, then this down it will be 100 factorial by 100 minus 2 factorial into 2 factorial. Okay, so that you can give like 100 into 99 into 98 factorial by 100 minus 2 factorial into 2 factorial. Okay, so here 20 minus 2 factorial and 18 factorial will cancel, then 80 factorial, anyway it will be coming as 1, then 100 minus 2 and 98 factorial will be coming like this. So at the end you will be getting like 19 by 495. Okay, so I think it's clear. Okay, yeah, any doubts you can ask, or I'll be moving on. Okay, now distributions. So in distributions there are binomial, Gaussian. Okay, so binomial is given by NCX, actually this one. Okay, Jason, 20 by 100 into 19 by 99. Okay. What will it come to? Similarly, it will come same, right? Wait, I will just inform how it will be happening. Okay, 20 into 100. Okay, you are selecting it like that. Yes. So what answer you are getting, Jason? Yes, that is right. So this is how you can select it. Okay, you can just see 20 into 100 by this thing, that like that you can calculate, but when the number of cases becomes more, then this method is fine. Okay, because okay, Vishal Patil has raised a hand. What is your doubt, Vishal? Okay, anyway, this will I'll tell. I mean, in the first case, when nothing is selected, the number of defective is 20 and the total number is 100. That is right. And in the second what to say, in the second pickup, it will be like, so in that case you will be telling it as what you say, first one object is selected and then the another object is selected. Okay, so if when the first thing is selected, the probability will be this one, and after taking one out, then the total number will be 99 and the next one will be 19. Okay, so that is what Jason has told. This is fine, but when you have a total number of cases very different, okay, so this is like only 2 are selected. Can you okay, yeah, I'll explain. So in that cases, and if you have more numbers, for example 5 taken together and all, then it is better for you to go with this method. Okay, with the combination method. Then can you explain combination being taken? So combination is like Durga, are you speaking something? Okay, yeah. So combination means okay, I'll say with this thing itself. So there are totally 100 things. Okay, so in that we know that 20 items are defective and 80 are non-defective. Okay, our first intention is to take 2 out of that. So it's like classes, yes, every day from 6 to 8. That is right. Okay, so whenever you want to select something, okay, like for example when you want to find I think you have seen permutations and combinations. Okay, permutations you will usually use when you want to arrange some things. Okay, so if your example, for example if we have defective as a word, okay, if you want to see how many times we can arrange it, then we have to see how many things it is, how many times it is repeating, and how many times we can arrange this thing. So in this one we are not taking anything out. Okay, so I think I'll go with another one. Okay, so in the combination case, recordings will be shared in the Google Drive, Vishal. Okay, yeah, so in our case, for example, if you have 3 red balls and 8 blue balls, then there are a total of actually 11 balls. Okay, so if you want to say like you have to take 2 red and 4 blue from this, then it is like the combination. Okay, like here also there are 2 types in a pile. One pile is there, one pile of 100 items are there. In that 2 different items are there. Okay, so this taking what you say, selecting 2 from the whole pile can be written as 100C2. Okay, that means 2 things are taken from 100 items. Okay, and selecting from different cases. Okay, for example, there are 20 defective, so in that defective things itself you will be selecting 2 items. So there you have to take C, combinations, but because you are not arranging it. Okay, so for example, let me see if I can point you to some things actually. Okay, so maybe you can just see some things on that. For example, so it's like I think the combination, the basics, I think I'll share you some videos. Okay, who had asked that? Iron up. Okay, so that you can refer. Okay, 2C2. Drive link will be available in the, just wait for a moment. Drive link will be available in the problem solving session, under the problem solving session. Okay, so wait a moment, what was that? 20C2. 20C2 means yeah, 20 into 19 by, it's not 1 written, I mean, okay, like for example, combination, I'll write here, combination, I think it's visible, right? Combinations, if you have total number as n, and you have to take r from that, r items from that. Okay, so it's given as NCR. Okay, so NCR means n factorial by n minus r factorial into r factorial. Okay, so that means like you have given, it will be 20 factorial by 20 minus r is 2 here, 2 factorial into 2 factorial, that means 20 minus 2 is 18 factorial. Okay, so you can, that's why I had written 20 into 19 into 18 factorial by 18 factorial into 2 factorial. Okay, so it will be like 20 into 19 divided by 2. You can write 2 actually. 20 into 19 by 2. Okay. So can you say Bayes theorem? Where is Bayes theorem used usually? Chandan, can you tell me where you will usually use that? Okay, I mean like Bayes theorem we will reach, I mean just okay, I mean Bayes theorem is usually calculated when we want to find the probability of one event with respect to an event which has already happened, right? Okay, so that is like yeah, so in here what is the different events happening? I mean the events are same, like right, like I mean they are drawing out 2 defective items from a set of 100 items. Okay, in another case, if for example, if you have in a pile different sets, like for example some square items and some round items, okay, and from that, and in that itself some defective items are there. So first, if you have the probability of round as well as square, and then in that if you want to find the defective, then you can say like the probability of occurrence of defective related to any other condition. So in that case you can use the Bayes theorem. Okay, yeah, so I mean we'll come to examples with that. Okay, yes, yeah, so we'll move on to distributions. So first one, binomial. Okay, I was speaking with this n factorial by n minus x factorial into x factorial, p raised to x, q raised to n minus x. So all these are written here. N is the number of trials or the number being sampled, x is the number of successes desired, p is the probability of getting success in one trial, and q is the probability of getting failure. We'll see this with an example. Then another distribution is there, Gaussian distribution, where p of x is equal to 1 by sigma root 2 pi e raised to minus 1 by 2 x minus mu by sigma the whole square, where sigma is the standard deviation and mu is the mean. So these all you have seen in your lectures. Then statistical sampling. So in that there will be a whole for example in this figure you can see a whole population here, and from that population some people are sampled. So this is a sample of some set in the population. Okay, so population is the set of all possible outcomes of a random experiment, and sample set is the finite set of observation obtained from the experiment. Okay, so why do you use the sampling? I mean you might have seen in this in the videos, sampling will help to make inferences about the population, and the inference may be uncertain because the samples might be uncertain. Okay, so if you see the statistical analysis, you can see descriptive as well as inferential. So in the descriptive you can get with the help of a graphical as well as numerical, the presenting the data in plots as well as numerical, summarizing the sample set. Then in inferential there will be the estimation as well as hypothesis testing. So in our case we have concentrated more on hypothesis testing, so making judgment about f of x. So we'll move on to that. So first, this is the graphical statistics that you have seen. So who has raised the hand? Okay, So there is a scatter plot. This you'll usually see. This, for example, is given between an average daily temperature as well as the visitors coming to a place. So how many visitors are coming to a beach in a particular time period. So based on the temperature, the number of visitors are varying. Okay, so this is a scatter plot which shows the relation. Now there is a histogram plot also. The histogram plot, it is like for an interval it is given. So this is like a plot between the like body temperature. So this is kind of forming a curve. Okay, a bell-shaped curve it is forming. There is some differences at the ends, but it is here it's forming like a Gaussian curve. Then there is the box plot. Box plot was also explained in the lecture. So here you can see the different terms mentioned. There is a median, upper quartile, lower quartile, minimum and maximum. So these are given as the whiskers. So if you draw the box plot of a particular data distribution, then the median will come about at the 50% of the whole population. The lower quartile or the Q1 will give you the 25% of the observation lie in this particular area, and the upper quartile will give you that the 75% is lying in this particular level. Okay, so you might have seen box plot in the lectures also. How we'll plot this and all we'll see when during the case studies, so then you will understand it more clearly. Then there is the numerical statistics. So numerical statistics, this you have seen many times in statistics. So mean is the average or norm. So if you have a set of these different values 1, 3, 4, 6, 6, 7, 8, then the total addition of that by the total number will give you the mean. Now the median will be the middle value. So in this particular case the middle value will be this one, and there is the mode, which is the most frequent value given by this one. Okay, so the range will be the difference between the lowest and the highest value in a particular set of values. It will be 8 minus 1, which is given by 7. So this is just a description, okay, of that. Now we look at the covariance and correlation. So covariance indicates the direction of the linear relationship between variables. Okay, direction of the linear relationship between variables. Then covariance values will not be standardized. The value can be anything. Okay, so the equation, the formula for that is I equal to 1 to n, summation I equal to 1 to n, xi minus x bar into yi minus y bar by total number. So it only indicates the direction of the linear relationship between variables. Now if you want to get the strength as well as direction of the relationship between two variables, you have to go for the correlation. Okay, so in correlation values are standardized and the value will lie between minus 1 and plus 1. Okay, so correlation is given as covariance of xy by sigma x into sigma y. Okay, so these all you have seen, this is the standard deviation, these both are standard deviations. Okay, now hypothesis testing. So hypothesis testing is used when we want to make decisions. Okay, this is the base of all the things that you'll be doing later. So the thing is whether the drug of A, effect of drug A is similar to drug B. This later comes in many classifications and all when you are doing classifications also. So the hypothesis testing is generally converted to a test of mean and various parameter of the population. So here covariance can be given like So covariance, it's like a direction. Okay, like for example, usually what is variance? Variance will be like how much variance will be from the, how much variance of the elements will be from the mean of that set of elements. Okay, so now you will be checking between two variables. Okay, so there are set of x values and set of y values, and there will be total number. Okay, so it will be like whenever so covariance usually means like it indicates the direction. That means like so if you see for example the relationship between two values, it's like two random variables might be there, and when one of the variable is increasing. Okay, so when one of the variable is high, you want to see how the other variable is changing. Okay, so for example, in a particular graph, if you see, if you are looking at the average daily temperature, okay, it is varying like this: 80, 84, 80, 88, 92, 96. So when we give a set of values, just wait, I'll admit one person. Yeah, so here you can see, like, I mean, some different values are there, like for example 82 is here, 84, then 86. So it's varying like this. Okay, so some set of values will be coming like 80, 82, 84, 86, two occurrences like that, it's going. Okay, so this is the values for the temperature, and in the other case, number of visitors is going like in between, I mean the correct value, it will be like come somewhere around 80, and the next this portion is 225, then 300, 350, like that, something like that, it's going. Okay, so you will find the variation in this one, and you will find the mean of the temperature values which is observed. You will also find the mean of the visitors there, and you will find the variations. Okay, so what this things show is that, so here the equation is like xi minus x bar. So x bar will be the mean of one set of values. For example, if you are taking between the average daily temperature as well as the number of visitors, the mean of number of visitors will denote here y bar, and the mean of the temperature will denote x bar, and from all these values you will calculate the x minus x bar and y minus y bar. So when you see that, you can find out how the variation is going. Okay, for example, in this one, the covariance, when you try, you will be getting a positive value. For example, why is it happening? I mean, in spite of some of the occurrences out of that relation, you can see that whenever the average daily temperature is increasing, the number of visitors is also increasing, right? There is that relationship between that. So when you find out the covariance, it will be coming like a positive value. Okay, so when you calculate this one at the end, you will be getting a positive value, which will denote that whenever the one of the parameter is increasing, the other also is increasing. But in this case, if you get a negative value, it will mean that when one parameter is increasing. Okay, when a negative covariance will mean that when one variable is high, so the other variable will be low. So in that cases will be the places where the graph will be showing a relationship like this. Okay, I mean the scatter plot will be showing a relationship like this. That means, for example, as long as this value is increasing, so if this is the positive axis, then the other value, the axis is like this, so the other value keeps on decreasing. Okay, in that cases, if you calculate the covariance for this particular plot, it will come as negative. So this particular thing is usually used to find out the direction of linear relationship. So for example, when at the end, if you are doing a case study of some particular things, like for example, I think you can take the example of a biomedical data set, and okay, if you are seeing like the glucose value as well as the insulin values, for example. Okay, so or there is another parameter. Okay, so if there is an increase in glucose values, wait, okay, if there is an increase in glucose values, there is, I mean, for this particular example, I'll be telling like there will be two parameters. One has an inverse relation. Okay, one has an inverse relation with the glucose values. So this is the one which has an inverse relation. So inverse relation means as long as the glucose value is increasing, this value will be decreasing. Okay, so if you plot these two, you will be getting an inverse values, like when this is increasing, this will be decreasing. Okay, there is some formula between that. So whenever you are getting two parameters, so in a big data set there will be like different features available, right? In big data set there will be different set of features. Okay, so when you want to see how this particular first feature is related to the third feature, you can check the covariance first. Okay, so covariance will tell you when one of your parameters is increasing, how your other feature behaves. Okay, so that is covariance. But usually in the case of data sets, you will directly go for correlation. Okay, because correlation will give both the strength, how much it is related, as well as the direction of the linear relationship. Okay, so covariance, correlation is calculated with help of covariance only, divided by sigma x into sigma y. So this is usually used in the practical cases where you want to find out the strength. So this will give like, so for example, if you find the correlation between quickie, this particular value quickie and glucose, then it will show you like a value like point, if you get it like 0.05 or something, then this is the strength of both those features. And if you get a minus value here, then it will mean that it is inversely related. Okay, so that is correlation and covariance. Okay, so Vishal, are you fine with that? Okay, so we'll move on to the next one. So hypothesis testing. So this one also is clearly mentioned there. So here, like, we are checking whether the effect of drug A is similar to the drug B. So this is the basic case of many classifications, everything that you will be seeing in the next weeks, in the coming weeks. So here, now an example is like, there are different types. Okay, it's generally converted to a test of mean and variance parameters. So there are a two-tailed as well as left-tailed and right-tailed. So the detailed description is available in the week lecture videos. So here, if you have the distributions like this, okay, you will be mentioning a threshold value. Okay, so below that threshold value and above that threshold value, you have to reject your hypothesis. Okay, so first you will be starting with a null hypothesis. So null hypothesis, usually you will tell, like, for example, in the case of a population, you will tell that the population mean will be equal to a particular value, and the alternate hypothesis for that will be like it's not equal to that particular value. Okay, so if this you are telling, we are considering about the two different regions. Okay, and in between that region we won't reject the null hypothesis, and after that particular threshold we will be rejecting the hypothesis. Okay, so rejecting H0 means then the alternate hypothesis is accepted. Okay, so Similarly, there are one-tailed, like left-tailed means this, if this mu is greater than or equal to 23, then we don't reject H naught, and the alternate hypothesis is less than 23. Okay. Then there is right-tailed also, which is the reverse of this particular case. Okay. So here you can see an example. So here it is like application, the null hypothesis we are taking like application of biofertilizer X do not increase the plant growth. Okay, that is the null hypothesis. And next thing we are telling like the alternate hypothesis is like application of biofertilizer will increase plant growth. Okay, so null hypothesis usually you can tell like is a hypothesis which the researcher tries to disprove or nullify, and alternate one is a hypothesis which the researcher tries to prove. Okay, so this is the practical case. Then you might have seen the errors also, like for example there are different cases. The truth can be like H naught is true or alternate hypothesis is true, and based on our calculations maybe we will take the decisions like H naught, which is null hypothesis, is not rejected, or null hypothesis is rejected. Okay, so in this particular case, if this thing is true as well as H naught is not rejected, it will come to the correct decision, and its probability is given like 1 minus alpha. So in the case where the null hypothesis is true, but if we are rejecting the null hypothesis, then it will lead to type 1 error. So type 1 error probability is given by alpha. So this alpha is normally known as the level of significance of the test. Okay, so level of significance of the test means is given by the null hypothesis is true, but we have rejected the null hypothesis. Okay, and it is controlled by choosing the criterion from the distribution of test statistic under the null hypothesis. So there is another thing. So if you look at the total of this particular case, 1 minus alpha plus alpha will be amounting to 1 itself. This is the total probability, which is equal to 1. Another case is like when if the alternate hypothesis is true, we have to reject the null one. Okay, but some cases we might not be rejecting it, so it will result in type 2 error, and that probability is given by beta, and the correct decision will be the probability equal to 1 minus beta. So this also will be amounting to 1, the total probability. So you might have seen, based on this you might have seen a graph which shows the trade-off between the two cases. Like for example in this particular case you might have seen a graph which shows null hypothesis, and another thing which will show how to accept this one, and then when you select a particular threshold, this particular thing will denote your alpha, and here this particular portion will denote the beta. So whenever you are changing the, if this particular thing will, if this is for H alternate hypothesis and this is for H naught, then this will denote beta and this will denote alpha. Okay, so you can see that when we change this particular level, okay, when we bring this level to the left side or right side, the alpha if you bring it to this side, the alpha value will be increasing and beta will be decreasing. So if you want to include more things in the null hypothesis region, then if you have to bring this to the right side, and if you do that, alpha will be reducing, beta will be increasing. So there is a trade-off. This also you have seen in the lecture videos. Okay, so this is the basic, these are the basic things which were in this particular week. We'll move on to the assignments. Okay, so first question, you can also try this one and you can put the answers in the chat window. So first thing is like Sumit wants to contact one of his friends, but he remembers only the first 9 of the 10 digits of the contact number. He is sure that the last digit, what is the error in that? Okay, where are you asking that error, Ainab? The previous one? error two errors are there, okay? Two errors are there totally. There is the type 1 error, okay? So type 1 error comes when you have the h naught as true, okay? Your null hypothesis is true and decision has come as h naught rejected. That means it's a false case, right? I mean, you had to accept the null hypothesis, but it is rejected, okay? So that is one type of error. It is an error, okay? When your null hypothesis is true, you have to accept the null hypothesis, then only it will be the correct decision, okay? So if that is not done, then there will be an error, okay? So that error will tell you the significance of the test, okay? So that means that that probability will give the significance. That means that that particular feature that we are identifying, for example, if we are looking at different features in the particular example, and using that feature, if we are forming some hypothesis, and in that hypothesis the hypothesis was supposed to be true, I mean, we should have taken the decision as true, but after calculation and everything we have rejected it. That means that the significance of that test is what you will say. By that way you will see the significance of that test, okay? So this we will see in the examples, then it will become more clear, okay? I know. So there is another error also. So the difference is like, so for example, if this is the shape, this is the curve denoting the null hypothesis, and you have another curve denoting the alternate hypothesis, okay? There will be some overlapping there, okay? So I am putting it as h naught and h1, and I am giving some level, some threshold. I am putting like one level of threshold, I am putting like this, okay? So this is our threshold. So in the first case, this threshold value, okay, this is the threshold value. So if you're looking at a one-tailed test, okay, one-tailed hypothesis test, then in this region, this particular region, we will be accepting h naught, right? After this threshold only we will be rejecting. This particular region we are trying to reject, okay? That is one of the things. So but in you check in this case, for the h1 case, from here it will be accepted. So for the h1 case, this is the threshold, okay? So before the threshold, whatever is present will be rejected, okay? Because this level means that h naught will be accepted. So in that case h1 will be rejected, okay? So this is the place where the beta error is coming, the other place alpha error will be coming. So one thing that I was telling is like, when you move this threshold value, okay, for example, if you move it to this side, then it will be like the alpha error will be increasing. Alpha is denoted by this red portion, okay? So if you move this line to this side, this red portion will be increasing, right? Okay, so it means that more part of the null hypothesis will be rejected, okay? But in that same case, the beta portion will be decreasing also, right? If you move this line to the left side, the beta portion will be decreasing, okay? So that is the trade-off, okay? So I know, is it clear? Okay, I hope it's clear. Okay, so we'll move on to the question. Okay, and does everyone has the problem of the video freezing? Okay, okay. Okay, Ainab, you just, I think you can log out and log in again, okay, once. Okay. Yeah, it'll be clear. Usually you will tell like alpha you have to reduce more, but it depends, okay. Later we'll come on to that. Later we will see like some other values like usually in the classification case and all, we will be defining the parameters like true positive, true negative, false positive and false negative. Okay, so in that case we'll discuss that with an example. Okay, Ramya, then we'll see which one is dangerous with respect to a particular application. Okay, yeah. So yeah, this is has anyone solved this question? Okay, so how will you start this one? I mean, he has a number with 10 digits and the last digit he doesn't remember. Okay, like 1 2 3 4 5 6 7 8 9 10. Okay, so this last digit he doesn't remember, but he knows that it is an odd number. He knows that this value is an odd number. He selects an odd number randomly. So if the random variable x denotes the last digit of the contact number, then calculate the variance of x. Okay, so can you tell me what will be the total number of digits that can come in that place? Total number, yeah, 10, 0 to 9, that much is there. And how much is the random variable, can you tell? I mean, number of the odd numbers will be 5, so the random variable, yeah, will be like, I mean, the occurrences is like 1 3 5 7 9, right? That is the occurrence. Okay, so how can you solve this? Just these are the random variable occurrences. Okay, so you are asked to calculate the variance. So for variance, what you have to calculate? First you have to calculate the mean, then you have to calculate x minus x bar or x minus mu, whatever you are naming that, and then you have to calculate x minus x bar the whole square, and then you have to find the mean again of this one. Okay, sorry, x minus, I mean like the expectation of x minus x bar the whole square will give you the variance of x. So how will you find it? Have anyone found out the answer? Okay, just we'll start this one. Okay, so what is the mean coming? X bar or mu will be coming like how much? It will be 5. Okay, like 7 plus 9 plus 7 plus 5 plus 3 plus 1 divided by 5. It will be coming like 5 itself. Okay, yeah. Then x minus mu I'll give. X minus mu will be like, just I'll give that, I mean minus 4 minus 2 0 2 4. It will be coming like this. Okay, and just to square this one, it will be coming like 16 4 0 4 16, and expectation of x minus mu the whole square will be the sum of these particular things. So it will be coming around 32 plus 30, sorry 40 divided by total number is 5, answer will be 8. Okay, so the answer here is 8. I hope everyone is clear with that. Yeah, so the next one, I'll move on to the next one. So suppose x is given as a normal distribution with mean mu and variance 4. Then for n equal to 20 IID samples of x, then the observed sample mean is 5.2. Okay, so what all are given? N is given, and n is given as 20. Then observed sample mean I'll give as x bar, it is equal to 5.2. Then we are asked to find out the conclusion of an Z test. Okay, if the null hypothesis assumes mu equal to 5. So our null hypothesis H0 means mu equal to 5 against an alternate hypothesis which is given as mu not equal to 5. Okay, and we are asked to find it at a significance level of 0.05. That means a 95% confidence interval. That means that if you have a particular curve like this, okay, then it will be coming like 2 sigma minus 2 sigma, you will say, where the 95% of the values will lie. Okay, yeah, so okay, you have to find out what conclusion. Either you have to find out whether the H0 will be accepted or the H0 will be rejected. Can you tell me? So first what you have to do, you have to find out the set score in this particular case. Okay, Chandan has given accept H0. Okay, so before that, one particular value for confidence interval 0.05, the value should be given. How much should be the value? Like 1.645 something is there. Okay, so if that value is coming above that, okay, you can accept. Okay, I mean below that you can accept. Okay, so just you have to see what is the value coming, z value. So you have to calculate it. How can you calculate it? The equation is like x bar minus mu by s, which is the standard deviation given by the root n. So s is given, sigma by root n. So okay, so what I mean, this is one of the things, and you are given like sigma square as 4. Okay, that also you are given. Okay, so can you tell me what is the answer you are getting? Why have you given accept H0, Chandan? Okay, because you know, if anyone can calculate it, I will calculate it now. So it will be coming like 5.2 minus 5, okay, by this thing, right? So I'll write this here. It will be 5.2 minus for example 5 by this thing will be coming like, you can give it like, okay, 2 by root n will be coming like 10. So somewhere around 0.447 is coming. Okay, anyway, this is well between the value which is given for this particular level. Okay, so that's why we will be accepting H0. Okay, yeah, n is equal to 20. I'm sorry. Anyway, it will be coming like 0.2 by 2 by it's root 20 only. It will be coming like 2 root 5. Okay, the answer will be coming this one, like this something. Okay, oh, it's 4 5 4 5. Okay, yeah, okay then. Okay, if you have got it like that. Okay, let me see. Okay, I think you're right, Ramya. Okay, if anyone else is getting that answer, it's okay. Okay, so anyway, I got around this value. So we'll move on to the next question. Anyone has any doubt? This is usually given in this way. Okay, x belongs to a normal distribution with, usually you will give it like mean and the variance. This is a kind of representation. One point, where it is that? Okay, that so hypothesis will be accepted. So okay, just let me change the screen to some other thing. For example, wait for a moment. Okay, I will so how can you say that? Yeah, 95% confidence interval set score. Okay, so for a value of set for a confidence interval of 95% is 1.96. Okay, I think 1.645 told. It's okay. That is for 90%. Right, 90. Yeah, that is 90%. That was a mistake. Okay. Yeah, 95% interval is 1.96. So Natarajan. Okay, so that means like, I think I have kept something values. Okay, I'll show you one thing where you can calculate this one. Okay, so in this particular, if what we are calculating is less than this particular value, you can accept the null hypothesis. Okay, that is the thing. Okay, you can see the different things here for different values. These are the values of, yeah. So okay, we'll move on back to the question. Okay, so I think where have I? Okay, I haven't written anywhere. Yeah. Okay, so the next question, anything else? Hypothesis accepted. Yeah, I think I have explained. If it is coming below that value, okay, then you can accept that. Yeah. Okay, so I have given, I mean, you can calculate this in RStudio also. So just we will see this one. Okay, suppose the IQ of a certain population is normally distributed. So this is how it was written. Okay, so for a certain population, X was normally distributed with mean of 100 and standard deviation of 15 or 15 square it will come. Okay. So usually you will say like that, mean of mu and standard deviation this much, or mean and variance you will tell. Okay, so a scientist wants to know if a new medication affects IQ levels. So she recruits 20 patients to use it for 1 month and records their IQ levels at the end of 1 month. Okay, so there is a whole population there. You have to find you want to find out the IQ of that population when a new medication is given. Okay, so the thing is, you can't take values from the whole population. So what she does is, she recruits 20 patients from that particular population. So that will mean the sample from that population to use it for 1 month, and then she'll record the IQ of those 20 patients. Okay, so just I'll show a code to show how to perform a one sample set test in R to determine if the new medication causes a significant difference in IQ levels. Okay, so we'll move on to the RStudio. Yeah, so this is the IQ levels. Okay, so just I'll tell you what all the things are given. So population mean is given as 100, right? And the standard deviation is given here as 15. Then the number of people which is there in the sample is 20, and anything else is there? No, nothing else is given. So from this particular values, you have the set of values given here. Okay, so from that set of values you can find out the x bar, that means the sample mean. X bar will denote the sample mean. So directly you don't have to solve all these things here, you can directly go to the R Studio, and I have given the values here. Okay, these are the values 88, 92, 94, 95, 115. Okay, so I have given that to data. Now for performing set test you need a library. Okay, so you have to install that one. That library is known as BSDA. So now I have included in my console and my programming environment. So this BSDA, if it is not given, I mean if it's not present, then you have to install that package. Okay, like what I have given last time. Just I will increase the size of this one. So I hope this is clear now. Is this window clear now? Okay, which size will be clear, you just tell. If it's I hope this is clear. Okay, so to perform the one sample set test, what you have to give? You have to give the data. Data means the sample, which is this particular thing, and then you have to give mu as the population mean, and sigma dot s means the standard deviation, okay, of that particular population. Now I'll run this particular line. So if I run this one, then this is one sample. Okay, so one sample means one tail set. Okay, so I have in this one the set score value is coming this much, and p value means probability of that one. Okay, so the mean, I mean the null hypothesis here was, okay, I will write that there. So in this particular case, the null hypothesis H naught will be mu equal to 100, and the alternate hypothesis H1 will be mu not equal to 100. Okay, yeah. So here when we did this one, the set score value was coming as 0.9, and the probability corresponding to that was coming as 0.3632. Okay, so this is less than 0.5 actually. Okay, so you can say that the alternate hypothesis is coming, okay, or the true mean is not equal to 100. So here the 95% confidence interval will be coming in between these values. Okay, so this is the whole set, and in that 95% confidence interval will be coming with these values, and in sample estimates they will be telling the sample mean. Okay, so 103.5 denotes the x bar. Okay, so R has calculated 103.5 as the sample mean. Okay, and the rest of the things, the z value, the p value, everything can be calculated here. Okay, now there is another thing also, if you want to have a two sample set test. Okay, so in this particular question, it's like write a code to show how to perform one sample set test in R to determine if the new medication causes a significant difference in IQ levels. So we have seen that. So the thing is, true mean is not equal to 100, so it causes a significant difference. Okay, now for example, if you have two cities, one city, if you have two cities where the medication is given, you will take samples from one city. So I have named it as city A, and another city is there, city B. So from this we have taken the IQ levels of 20 people from both the cities. So city A has this much, city B has this much. So, and in that I am performing the two sample test. So for two sample test you have to give x equal to how much and y equal to how much. So x equal to I have stored in city A and y I have stored in city B. Then the mean I am giving like mu, okay, it's not mentioned anyway. Mu I have to give as 100, okay, and sigma x standard deviation of 15 as x as 15. That means standard deviation in city 1 is 15 and city 2 is 15. So mu is like the population mean, okay. So both cities are considered there. So if I run the whole program, here I will get a result of a 2 sample set test, okay. So in that, data from city A and city B is there, set value coming like this, p value is very less. So since p value is very less, alternate hypothesis is selected, and the hypothesis is telling like true difference in mean is not equal to 100, okay. Then we are seeing the difference in mean, okay. Then these are the levels. So I think the difference in mean we are seeing about between different cities. That's why we are giving as mu equal to 0 for because in this particular case we are seeing the difference between city A and city B, okay. So once more I'll run this one, sorry. These are the two cities, and if I run this particular thing, so this was done sample test to find difference in IQ levels. If you have to find out it like that, IQ levels in two cities, then you have to give the mu as 0 because there shouldn't be any difference between the two of the cities. So if you run like this, then you can see the set value, p value like this. Here also, then also, I mean when you're checking it like that, it's not equal to 0, okay. And here they'll give you the mean of the first city and mean of the second city. So here itself you can see that there is a difference between both the cities, right? Okay, this is how you perform the set test in R, okay. So I have given, like, for more information I have given a link. You can click on this link and learn more about it, okay. Now, so we'll move on to the third question, okay. So this is, you can get the answer right away. The box contains 8 items, out of which 2 are defective. Similar problem we have done earlier. A sample of 5 items is to be selected randomly without replacement. Can you please, okay, that I'll share, okay. I mean I'll be sharing the RStudio file, okay, in the drive link, so you can take from there, okay. If you want, I can keep that also. Okay, but it will be, I mean it will be causing the mirroring effect, okay. I'll share that later, okay. Yeah, so yeah, this question, I mean similar to the one we have seen earlier, but here if random variable x represents the number of defective items in a selection of 5 items, find E of x, okay, that you have to do. I mean I'll give you a moment to calculate it, okay. Just calculate that one and find the answer. Either it will be 1.5 or 5, okay. So I'll start with solving actually. So 8 items are there total, right? N equal to total number. Total number is there 8, okay. And in that defective is 2. Maybe I can give it as D, and non-defective I'll give as ND as, anyway the rest of them are non-defective. so you have to select a sample of 5 items without replacement from the box. Okay, that is the intention. So the random variable is like either there is 0 defective, or there is 1 defective piece, or there are 2 defective items. That is the random variable which is available. Okay, so you are asked to find the expectation of x, right? So first we will check the probability that x equal to 0. This is little different from earlier. So x equal to 0. Yeah, so what is this actually? You have total number, that is 8, and from that 8, 5 are selected, right? And in the first case, the probability of x equal to 0, that means in the 5 elements which is taken, there are 0 defective items. So 0 defective items mean it is from 6C, 5. From the 6 non-defective items, we are selecting 5 items. Okay, so this will come around 6 into 5 factorial by 6 minus 5 factorial into 5 factorial. Okay, then here it will come like 8. I can write 8 into 7 into 6 into 5 factorial itself I can write, and here it will be 8 minus 5 factorial and 5 factorial. Yes, so 5 factorial will be cancelled. Here also it will be cancelled, so it will be coming like 6 by 1 thing will be coming. Okay, and 8 into 7 into 6 by 3 factorial. 3 factorial will be given like 3 into 2, that can be cancelled with this one, so the total will come like 6 by 56, around that. Okay, now in the next case, when probability for the second event x equal to 1, so that means probability of 1 defective among the 5, that will be, anyway the total will be same here, and 1 defective among the 5. So how many defectives are there? 2 are there and 1 is defective, and the rest are non-defective. That means total non-defective 6 by the rest of the thing will be 4. So you can solve this and tell me the answer. And next thing is probability of x equal to 2. That means probability of 2 defective. Okay, that means 2C2 into, the rest will be 6C3 by 8C5, right? These are the things. Okay, now so this will be coming around, if has anyone calculated this one? Okay, anyone? Anyway, it will be coming around 30 by 56. Just check with your answer. And this one will be coming around, let me see how much it is. Yeah, 20 by 56. Okay, so now you have to write the variables as well as their probabilities as in a table. Okay, so 0, 1, 2 and 6 by 56, 30 by 56, 20 by 56. So if you see the total, it will be coming around 1 itself. Okay, so the expectation of x will be like sigma x into p of x. Okay, so you have to give 0 into 6 by 56 plus 1 into, I'll just write it. Okay, 1 into 30 by 56 plus 2 into 20 by 56. So the total will be coming like 30 plus 40 by 56. Can you tell me the answer? It will be like 70 by 56. So it will be coming around 1.25. Okay. So the answer is 1.25. Any doubts in this problem? Okay, let's move on to the next one. So this you can just find out. Okay, so here the things given us, x belongs to a normal distribution with mean mu. Okay, and this one. Okay, normal distribution 9, mu and 9, and n is equal to 100. Yes, then observed sample mean 4065 into 20 for 1 will be very easy to calculate, ma'am. I didn't understand what you were saying. Jason? Okay, previous question. Two C0 into 65 for 1, 64 into 2C1. Yes, 63 into, yes. I didn't understand what you were trying to tell. It will be very easy to calculate means it is easy only. You want to see the calculation? Is that the question? HC5 in, no, I have to take the probability, right? Probability means what? The total occurrences will be coming in the denominator and the number of events will be coming in the numerator, right? So the total events will be HC5 and this one will be the number of occurrences. So you have given the same thing only. 65 into 2C0 is similar only. 2C0 will come to 1 actually. So this is 65 only. This is same only. I mean 2C0 is what? 1, right? Yeah. That's why I haven't put it there. Okay. Okay. So yeah, the previous question answer is 1.24. I mean in the question, in the options it was given as 1.25. okay, so you can check that answer. Okay, it's closer, it's coming like 1.24 something. Yeah. So okay, so the observed sample mean, this is the sample mean, sorry, sample mean I'll denote as x bar. Okay, yep, it's x bar and it's given as 11.8. So your null hypothesis is given as mu equal to 10.5. Alternate hypothesis then will be not equal to 10.5. okay, yeah. So just everyone check this answer, how are you getting this one? Okay, yeah. How can you solve that one? The same equation only, set score. For set score you can give like x bar minus mu by sigma by root n. Okay, yes. and it will be coming around 4.333. okay, yes. So this critical value, if you see, just search, okay, critical value will come around 1.645, and just like we have given two significance levels here, okay, significant levels of 0.05 as well as 0.10. So if you check in your documentation, okay, or just type the critical value for, this is like two-tailed set test, right? So for two-tailed set test, critical value for confidence significance level of 0.10 and 0.05 you have to see, okay. So for 0.05 the confidence level, the critical value is 1.645, and for 0.10 the critical value is 1.2816. this you can search, okay, and you'll get these values. Just thing is like, this is like a two-tailed case, okay, there is one different values for one-tailed case. So if you see that, you can see the value is here 4.33, okay. In that case, what will you be having? In both cases it will be rejection of H0 at significance level and rejection of H0 at significant level of 0.05, okay. So both the cases you can put, right? Yeah, that is used actually, that standard deviation is used, okay. I have calculated it using that. The value will be 3, okay. Now this is a theory question. The sample of n observations are independently drawn from a normal distribution. So if you are drawing something from a sample from normal distribution, the sample variance will follow a chi-square distribution with n-1 degrees of freedom, okay. This you can search in your lectures, right? Then which one of the following is a best measure for central tendency of categorical data? So categorical data means you have different categories which will be repeating in your data. So if there is many repetitions and it is like different classes, for example, whether it is there is one example of iris data set, which means the flower colors, petal color and sepal color. So it's like with that different 3 classes are there, okay, Virginica. So 3 classes are there. So in that particular data set, the result will be either of the 3 classes, and there will be repetition of these 3 classes in the data set. So in such particular cases, the best measure of central tendency will be mode, okay. I think you have seen this in your lectures, right? Yes. So people are still joining only, okay, yeah. So x and y are 2 independent random variables. This is an easy question, you can find it out directly. Variance of x given as 9, variance of y is given as 3. You have to find the variance of 4x minus 2y plus 6. So this is the equation behind that. If you have ax plus by plus c, then it can be written as a square into variance of x plus b square into variance of y. Similarly, in that case, you can write it as 4 square into variance of x plus 2 square into variance of y, okay. That is why it is coming like 16 variance of x plus 4 variance of y. So if you calculate that, you will be getting the answer as 156. This is an easy question, okay. I hope that is clear. Next is calculate the standard error of a sample mean using the following data. N is equal to 14, mu is equal to 18.5, x bar equal to 17.85 and s equal to 1.95. So everything is given. Just use this formula. Standard error is equal to s by root n. That means 1.95 divided by root 14. The answer will be 0.52. Okay, these are all direct application of the formulas. Now another thing, this is the covariance and correlation. Okay, so correlation coefficient of two random variables x and y is given as minus 1.4. Variances are given by 3 and 5. That means then sigma x in that case will be root 5, that means standard deviation, and sigma y will be root 3 and root 5. Okay, so these are all the values which are given. If you want to find the correlation between x and y, you have to find out the covariance xy by sigma x into sigma y. Okay, so right now you have the correlation as well as sigma x as well as sigma y. So you have to find out the covariance. Use this formula, substitute in that, you will get the answer as this one. So here the covariance is coming as negative, right? So negative indicates there is a negative relationship. Okay. So next one, find the t statistics of the sample data given that the population mean of the distribution is 8. So we'll just move on to the R studio for getting the answers. So here, I mean, the usual case will be like you have to find out the mean from these set of values, then you have to find the variations, then you want to find out the standard deviation also, then you have to give it in the t-set test values you have to find. So instead of doing all that, just input these values as a program. Okay, so how you will do that? I'll move on to the R studio for this one. Okay, so this is the 10th question we are checking. 5, 5, 7, 5, like this values are present. Okay, these are the samples. So C of these values, we want to find the t-test. So t dot test. So for z test we gave z dot test here. So t dot test is for t-test and samples and mu equal to 8. So the mean of the population, mean of the distribution is given as 8. So you can find like this. So I have just given the formula also, x bar minus mu by s by root n. Okay, for t-test based on the student t distribution, this one. Okay, so you just have to run this program here. So if you run that one, it will tell you like one sample t-test. Okay, one sample t-test data is from samples, which is the list of these particular values. Then you will be getting these values. In t-test you have the degrees of freedom, right? Yes, so that is like n minus 1. Okay, so 9 you'll be getting. Then p value you are getting, this was 1. So this is a very small value, so null hypothesis is rejected. So alternative hypothesis, true mean is not equal to 8. Okay, population mean is given as 8. So t statistics will be, so nothing else is given. So we are getting, since the p value is very less, we are taking the alternative hypothesis. Then mean of x is also given. Then 95% confidence interval is also given. So I'll be sharing this R file also. You can try this out. Okay. Now the next question, similar one only, but there is 2 sample data. So this also you have seen in your lecture videos. So this one we are asking for the F statistic. Okay. So the F statistic, sample data 1, sample data 2 are present. So I will be saving this to these 2 variables, sample 1 and sample 2. Okay, and var.test. Okay, that you have to run with sample 1 and sample 2. So if you run this one, you will be getting this particular F test to compare 2 variances. So now you don't have to solve it directly. I mean, you should just know how to solve it directly, but you can do this in RStudio also. So like this every value is present, and since we here also we are getting the alternative hypothesis true ratio of variances. So F test is usually used when we have to compare the ratio of variances. So the null hypothesis will be ratio of variances will be equal to 1, then the alternative will be the true ratio of variances not equal to 1. Okay, now they'll show you the variances also. Okay, right. Next one, the same thing. Here it will be like the sample is given. In the next one, the sample is also given with the population variances. Okay. So in that case, you have to input the two variances to sample X as well as sample Y, and I'll be mentioning the variances also. So variance of sample X, like this you have to give up. Okay, sample X by 3, variance of sample X is Y, then I will give a round off. Okay, so just I'll run this particular thing. Okay, if I run this particular thing, just the standard deviations will be given. Okay, so variance, the ratio will be directly obtained because the variances are already given. So you just have to find the variance of this data and divide by 3 will be giving you for the sample 1, and this one divided by 7 you will get it for sample 2. Then variance of sample by variance of this one with respect to 2 decimal places you can get for getting the value ratio of the 2 standard deviations. Okay, now this is another theory question. When will you reject the null hypothesis? Okay, so these are the options given: p value greater than alpha, less than alpha, equal to alpha, none of the above. Okay, so in this particular case, since p value is calculated value, we will compare our p value with alpha. So alpha is the level of significance of a test. So if p value is less than alpha, we will reject the null hypothesis. So this is just a theory question. P value should be less than alpha. When it will, in that case, we will reject the null hypothesis. Okay. Now a standard normal density function is shown. The area of the shared region is, okay, so you have to find the area of the shared region. So in here, this I'll just show interactive thing for this one. Okay, yes, so this one I'll just copy and just I'll paste here and show. Okay, so in this one you can see, okay, if you are looking like 0 to z up to z or z onwards, how much is the area? Okay, if you want to see, so this is like the set score standard normal distribution table. So if you are seeing it like this, at to z equal to 2, it's 47%, and then if it's like, if you want to see up to here, it's like this. So this is one sided, then two sided also is present. Okay, so this is one interactive thing that you can see. Okay, so this is the 100% of the table. Okay, so this much from the negative side till to the 2, it is coming like this. Okay, and if you are putting less than this one, this much is coming. Okay, so this is like the standard normal distribution table. If you can see different variations. Okay, so yeah, so different things are given here, like this is between minus 2 plus 2, so that it will include 95%, right? 95% is between minus 2 sigma and 2 sigma. So this answer will be 0.954. Google Drive, okay, then just let's wait a moment. I think it's given in the problem solving session, under the problem solving session. Anyway, I'll share it here. Let me just see here. Sorry. Okay, I will share it here. I think you can access that. Okay. Right. So that is this particular case. Now a talent exam is conducted annually which has a mean score of 200 and standard deviation of 30. If a student's set score is 1.50, what is the score in the exam? So this is like very easy. Mean is given as 200, standard deviation 30, set score is also given. So what was set score actually? I haven't come back. Yeah. So yeah, set score was, this is the simplest case actually, x minus mu by sigma. So you are asked to find out, sorry, x minus mu by sigma. X minus mu is the mean by sigma. So in that case, x will be like z into sigma plus mu. That is meant by mean plus z into standard deviation. So you have to print that. Just I have given that as in the R studio. Okay, mean I have given as 200, standard deviation 30, z value as 1.5. So x equal to mean plus z into standard deviation, print x. Okay, so you'll get the value 245. Now we'll move on to the next question. So a car company purchases engine blocks from suppliers A, B, C. 3 suppliers are there, A, B and C. Out of the 100 units supplied by A, 2 units were found to be defective. Similarly, out of the 200 units supplied by 200 and 300 units supplied by B and C, the number of defective units were 10 as well as 15 in the C case of C. So if a quality control person of the company picks up a block and if the block is selected from A, what is the probability that the block is defective? Okay, so you have total number of A as 100 and defective as 2. So here just the thing is asked from, taken from block A. Okay, so later we'll come on to the case where one is given, the next is taken. So right now only we have to check defective A by total number of A. So 2 by 100 will be getting as 0.2. This is the case where a block is selected from A and it is defective. Okay, this is direct question. Now we'll see this one actually. Okay, this one a little variation is there. So just I'll go to R studio for the previous one. This is straightforward only. You will get the value as 0.2. Now I will tell you this another question. Okay, in this another question it's given like supplier X provides 55% of the batteries. So X and Y are there. Supplier X provides 55% of the batteries and so Y will be like 45, right? And the supplier Y provides the rest. Okay, in that 5% of 55% is defective and 4% of all the batteries supplied from Y are defective. Now you are asked to find out a battery from the bulk. So the bulk will contain about the 100% of the thing. Okay, the 100% of the items, and you found it to be defective from the bulk. Okay, so what is the probability that it is from supplier X? So at the end it is like probability of defective given it is probability that it is X. So finally they are asking for the probability that it is from supplier X given that it is defective, that is asked. Okay, so first what you have to see is probability of defective given X. Okay, first you have to find out probability of defective when the thing is taken from X. Okay, so that particular case will be like coming like 5% or 55%, right? So it will be around like okay, let me come to one other way actually. So in this particular case, first is like probability of selecting the defective, probability of selecting a defective. Okay, one has given us 1 by 11. Okay, I'll come to that. Okay, so probability of selecting defective. Okay, so the selecting defective means like either it is taken from X or either it is taken as Y. Okay, so probability of it's like battery. Okay, so battery from X and it is defective, or probability of battery from Y and it is defective. Okay, so that is the case. So in this particular one, so probability from X and it is defective will come around like, for example, the probability, it will include probability that it is X as well as probability that it is defective. So 5% of earlier one, it was like 5% of things in X is defective. Okay, so battery from X means it is like 0.55, right? And probability that it is defective is like 5% of 0.55, so it is like 0.05. In this case it will be like batteries from Y will be 0.45, and in this particular thing itself the number of defective is 0.04. Okay, so in that case total probability of defective will be, since OR is coming, this will be added, these two will be added. Okay, so the answer will be coming like 0.0455. okay, that will be the answer, that probability of selecting defective. Okay, now you have to find out probability of X in the defective. Okay, that will be, you have seen it earlier, probability of X intersection defective divided by probability of defective. Okay, so in this case what will be coming, probability of X and intersection defective is like 0.05 into 0.55 divided by 0.0455. You can calculate this answer and that will be the answer to your question. Okay, yeah, so what will be coming, what is the answer for this particular one? Just I will calculate this one. Okay, 0.05 into 0.55 divided by 0.0455, it's coming like 0.6. okay, so that's the answer. Okay, so I think everyone has understood it. Is there any other questions? Okay, then I think we'll stop this session. Yes, okay, right. So these things, this RStudio file as well as the PPT will be shared in the Google Drive. I have posted the link also. I think you can click on that and it will go to that particular thing. Yes, okay everyone, have a nice day.